Hey everyone, myself Akshay Tripathi and I'm working as AI engineer at Shorthills AI. Today we are going to see how to fine-tune large language model Meta's Llama 3.1 using our custom dataset with the help of Hugging Face powerful tools. So why do we really need fine-tuning? It's because these large language models are not perfectly tailored to perform on a specific task. Fine-tuning allows us to adapt the model to our unique data and requirements. By that, we can improve the model performance. By the end of this video, you will get to know how to fine-tune Llama 3.1 using advanced techniques like PEFT and Lura, how to locally save it and push it to Hugging Face Hub. So let's jump into the video. Hey everyone, today we are diving into fine-tuning a large language model using Google Colab. We will be working with Meta Llama 3.1 model utilizing Hugging Face powerful tool to customize and deploy our fine-tuned model to Hugging Face Hub. So let's start. Llama 3.1 is the fourth iteration of Meta's language models known for their impressive capabilities in NLP tasks. Like its predecessors, Llama 3.1 is designed to understand and generate human-like text, making it incredibly useful for various applications from chatbots to the content creation. So without wasting time, let's have a look to the steps involved in fine-tuning. The very first step is to set up an environment that includes the necessary libraries, packages required for fine-tuning and inferencing of our model. Then we have to load our dataset on which we have to fine-tune the model, and the very important is Hugging Face client setup, through which we will load our pre-trained Llama 3.1 model, and then we will set up our PEFT configuration and training arguments for fine-tuning the model. After fine-tuning, we will evaluate and save the model, then we will push it to the Hugging Face Hub. So let's move to the Google Colab. Here the very first thing you have to do is to connect the runtime to T4. It will provide you the 15 GB GPU which is required for Llama inferencing and fine-tuning. As you can see, I have changed the runtime to T4. Now I can start my process. So the first thing first, we need to install the necessary packages that are Hugging Face Transformer library, datasets, accelerate, bits and bytes, and the PEFT. These installation gave us access to the Hugging Face Transformer models, datasets, and specialized tools like bits and bytes for efficient model loading. It will take some time. Let's wait. As you can see, our required packages have been installed. So now let's move to the next step of loading our dataset. In this case, I have prepared a JSON file. You can have a look. That includes an instruction that is reverse the order of word with punctuations and keep the punctuations in the place, and input and then respected response. Feel free to adapt this to your own custom data source. Now let's load the dataset. Here you can see I have uploaded my dataset.json file to the Colab, and from here I can access it. Then I have also given a test size 2.2, which will split the dataset into training and testing set, reserving 20% of dataset for evaluation. Now as you can see, our dataset have been loaded. Let's move to the next step of Hugging Face client setup. For Hugging Face client setup, you need an access token that you can get from your Hugging Face account. You can go to your Hugging Face account and then the settings. In the settings, you get the option to access token. Here you can create a new token by clicking on it and you can give any name to your token, like I can give Llama 3.1, and as per your requirement you can give permission to this token and select the permissions, and you can then from here can create the token. After getting token, you will get the token, and then from there you can put that Hugging Face token to the secret keys in the collab. Like I have already set here to Hugging Face key, you can add a new secret key here and put the key as a value and name Hugging Face key, so that you can access here securely. Now let's get back to our process. To interact with Hugging Face Hub, you will need to set up the client. We will install Hugging Face Hub and logging into Hugging Face Hub using the access token. As you can see, I have already added a access token to my secret keys. I can access it through Google Colab user data and log into Hugging Face Hub. Now I have login successfully. Now let's move to the next step of loading our pre-trained model through transformer library. So now let's load the Llama 3.1 model and its tokenizer using transformers library of Hugging Face. As you can see, our inferencing has been started. It will take some time, so let's wait till our model and tokenizer being loading. Now as you can see, our 4-bit quantized Llama 3.1 8-bit instruct has been loaded with this tokenizer successfully. We can move to the next step. Now yes, check if the tokenizer has padding token. If it doesn't have a tokenizer pad token, set the padding token to the end of sequence token, that is ES token. And here is a function, tokenization function. As now the tokenizer is being ready, we will prepare our data set by converting text into tokenized input, that are numerical values, to fine tune our model. This function will ensure that our model receives properly formatted data into inputs and labels form. After preparing our data set, let's move to the next part, that is setting up our Lura configuration. To optimize our model further, we will apply a low rank adaptation, in short Lura configuration, which is a technique to efficiently fine tune large models. Here we are using transformers library and PEFT to set up our PEFT configuration. Here I have set 8 to the rank of low rank matrices and scaling factor and drop out rate for LoRa layers. And after PEFT configuration, we will set up our training arguments, and this is very crucial while we are fine tuning our model. It's very crucial to select the batch size, epochs, evaluation strategy, save strategy according to your requirement and availability of hardware. Like you can see, currently I am utilizing 13.5 GB GPU from 15 GB GPU. And after setting up training arguments, using trainer class of Hugging Face library, we can train our model. So as you can see, our training has been started and we are getting here the matrices of steps, training loss and validation loss. Now after training, we can evaluate the model performance on test dataset. The evaluation steps provide the set of matrices that give us insight of how well our model is performing. Like here you can see I have three matrices, that is eval runtime, eval step per second, epoch and eval sample per second. While training, you can observe these matrices to understand the model performance, like whether the model is underfit, overfitted or just right. Lower the loss indicates that the model prediction are close to the actual target value, while accuracy reflects the percentage of our correct prediction. So now as you can see, our model has been fine-tuned. So let's move to the next step of saving our model locally and pushing it to the hub. Before pushing into the hub, you should create a model repository in your Hugging Face, like going here and create a new model, and from here you can create a new model repository from here and click on create model. I have already created one. So here you can see our fine-tuned model has been pushed to the Hugging Face. Now we can inference it through it and use it. Now let's inference our fine-tuned model from Hugging Face. For that, again you have to connect to T4 GPU, and for that you go to change runtime and connect to the T4 GPU, and as you can see we are connected. I'm again using transform library to inference our fine-tuned model, which is yes, we need a Hugging Face key to inference that. Just have to okay this. Now I can access it. So now let's inference our fine-tuned model using transformers library. Currently the required packages are being installed. So finally, let's load our fine-tuned model from the hub and see its performance. I have already installed the required libraries. Now let's load our fine-tuned model. Now you can see it's start loading. It will take some time, so let's wait for it. So as you can see, our fine-tuned model and its tokenizer has been loaded. Now we can inference it. So let's check out its results. So as I got instruction to reverse the order of word with punctuation and keep the punctuation in place in input, and the input is let's go to the park and shall we. So now here we get the output. It's working fine. So that's how you can fine tune Llama 3.1 on your own custom dataset and push it to hub, and then you can inference it wherever you want. So that's all from my side. Thank you. Happy coding.
I hope you guys have liked this video. If you have any doubt regarding any concept in the video, please let me know in the comment box section below.